explaining the working mechanism of laser activated irrigant and its action on microbial biofilm, a high speed imaging study by Rosalie, a group from Belgium, in 2022, published in the International Endodontic Journal. This is the first study visualizing and describing the effect of laser activated irrigation on biofilm in a root canal setting. Also, it investigates in depth the remote mode of action of laser activated irrigation with the tip positioned at the canal entrance, as its mechanism is not fully unrevealed. In this study, they used root canal model consist of dentin and glass wall to allow visualization of the canal space during activation, with a high-speed camera capturing 20-second activation series at 50,000 frames per second. They had three groups. First group, the model was filled with water containing glass microsphere to observe the fluid dynamics. The second model was containing one of three different biofilm types, such as apicalis or multiple species biofilm. And the third group was filled with water. As for the irrigant and the laser activation, the main or primary irrigant here was water. And for the laser setting, 2940 nanometer erbium YAG laser was used with the following setting: pulse energy 20 microjoule, pulse frequency 15 Hz, pulse duration 50 microseconds, and the fiber tip of 400 micrometer conical tip positioned at the canal orifice or 2 millimeter into the root canal for some experiments. Recording and analysis of each experiment lasted for 20 seconds, one activation cycle. High-speed recording were subjected to quantitative analysis measuring the size, lifespan, and timing of cavitation bubble, as well as velocity and movement amplitude of the canal content, and the qualitative analysis observing bubble dynamics, biofilm detachment pattern, and fluid movement. As per the result, during the impulsion of the primary bubble, smaller cavitation bubble emerged through the entire canal. This process began in the coronal canal part and continued in the apical direction. Expansion of these bubbles was followed by an impulsion, and its volumetric change over time span of a view of 100 microseconds resulted in a very rapid vertical movement of the canal content with a mean amplitude of 900 micrometers. The succession of these movements with every pulse resulted in biofilm detachment from the root canal walls and gradual displacement of the fragment coronally until they are completely removed. The pattern of the biofilm removed was the same for all groups. Laser activated irrigation was able to remove biofilm from the root canal models. So, to conclude, the hydrodynamic effect of laser activated irrigation is based on the generation of small cavitation bubbles through the entire canal, far from the primary bubble. Their volumetric oscillation resulted in smaller yet very fast vertical movement.